Okay, so far we've learned how to do basic math and to use some advanced math functions. We've also learned how to use for loops to do sums. In this little lesson, we're going to learn how to do comparisons and to make decisions on those comparisons. Making decisions on comparisons are called conditional statements. In particular, we're going to be looking at something called the if-else statement. So first of all, let's create our project from the beginning. So I'm going to come here, use the project wizard, walk through it again, use our compiler, browse to where I keep things, and I've got a directory here called if else. I'm going to save it here, and I'm going to give it a name, comparisons. I'm going to add this file as well, the usual files from functions. Now, comparisons.c, the file itself, is blank. There's a number of things that we need to include. We need to include the standard input-output library, so we can use printf. Okay. And if we're going to use printf, we need to include configure user.h so that we can make use of the user window, and later any device we use to display results. The way we create the main function is very simple. Int main void and in here there's a number of things we're going to do. I'm going to start with a variable called 10. I'm going to configure user to run at 9600 bits per second at 1 megahertz. That's the default speed of the computer chip. I'm going to have this program run forever. That's what this while one loop is for. I don't actually need this return 0 step, simply because the while one runs forever, we're never going to get down to this return state. Okay, so in this point we want to talk about comparisons. Now we've looked at comparisons a little bit. We could say, is A less than 100? We're used to a comment like that in mathematics. Or similarly, is A greater than 0? There are some other versions of these things that are fairly familiar in mathematics, but we need to get the notation right. A less than or equal to 100, for instance, says that all the numbers for A up to and including 100. There would be A greater than or equal to. We could ask if A is not equal to, say, the number 5. Okay. Notice this is an exclamation point followed by an equal sign. And the last one, usually the one that we would start with, is A equal to, say, 25. Notice that when you're doing a comparison, you use two equal signs. A single equal signs would make the variable A have the number 25. A double equal sign is the comparison. Often when there are problems in code, that's one of the very common mistakes, using a single equals instead of a double equals. Okay, so these are comparisons, The first piece of code that we want to use is an if statement. Okay. Now, in the if statement, you would use an expression like we've used up here. That statement is either true or false. And if the statement were true, this code gets run. For instance, we could have the statement, this is true, print out right here. Okay. So in the output, so what are we going to put in for the statement here? We could put in something like, if A is less than 100, we want to print this statement. And since we defined A as being 10, this should be true, so we should get that statement printed out. Now, we want to make sure, under the build options for the project, that the include search path includes functions. Okay. Apply. Okay. And we also want to use mplab sim. And in the output, we want to make sure we get that set up to be 1 megahertz and that we enable the USART to a window. Say OK. And now I'm going to build this and see if I have any errors. I've got unreachable code at line 24. In fact, it's line 23. Yeah, I can't get to return 0 because of the while loop in front of it. Nothing to worry about. Expression syntax. Ah, yes, the while loop is supposed to end with a semicolon. And I didn't end with a semicolon here. I erased it somehow. And that's the same comment here. Let's try rebuilding this, see what it says. Okay. Expression syntax. Okay, I'm going to remove the while 0. See if I can find my problem in here. There's a semicolon here, which should be there. Comments. Try again. Ah, whatever it was, I apparently fixed it, and now it's compiling. And then, oh, it didn't take so long to finish this time, so let's run and see what we have. This is true, what we expected. Well, the watchdog timer that we haven't shut off, we'll talk about that later again. So here we are. Let's stop. So this is the simple if statement. It only prints things out or executes what's in these braces in here if the statement inside is true. What if we want it to do one thing if true and another thing if false? Then we use something called the if-else statement. It's identical to this, except there's an addition. Else, open bracket, close bracket. And in here, we can have it print something else. So I'm going to change this to, is it less than 5? Okay, so in the if-else statement, this else is part of the if statement up here. Okay? This is the comparison that gets done. If the result is true, this gets done. If it's false, this gets done. Let's build. Wait for it to compile completely. It works well, so let's come here and let's just step through, well, clear the screen, clear page, and now step through, and as expected, the statement is false. In here, if you wish, in either piece, you could have more nested if-else statements. For instance, in here, you could say, if A is less than 3, else an if-else statement about A being less than 3. Or in here, if A was greater than 10. You could have embed these in here as many layers as you wish to go down. But we'll also talk about something called a switch statement later, which makes some of these things easier to do. One more thing I want to comment on is that it's possible to make even more complicated instructions here. And that's by using modifiers where you say, if this is true and that is true. So this guy is for and, double ampersands. You can also have or, which is 2 pipes. So this is or. And there's also, if you put in front of a statement an exclamation, something like this, right? So not A less than 5. Our A is 10, so it's not less than 5. A less than 5 would be false. Not false is true. So this is actually true. So you can use that exclamation mark on a statement to get the converse of the statement. So we can do combinations here. We can say if A is less than 5 and A percent 2 is not equal to 0. Okay. So you'll remember this is the, excuse me for a second, this is the modulo, right? So modulo 2 basically gives you the remainder of the number, and the only numbers can be 0 and 1, right? So this statement says, is it an even number? So this is A less than 5 and A even. Okay? Both those things would have to be true. So you can make quite complicated combinations here. And you can keep going. Not just 2, but 3 or 4. It just gets confusing the more comparisons you're doing inside the same statement. So let's see if I've got any typos in here. No typos. So it works. We'll see what we actually get out of it. The statement is false, right? Because A violates the first one. It's not less than 5, and it's also not an odd number. One last point to warn you about. If you were going to rate if you wanted to see if a plus 4 was less than 20. Doesn't matter what I'm actually comparing here. You have to be very careful here. Does that is it a plus a equal to a plus 4 less than 20? To make sure that your statement is interpreted the way you want it, you should put brackets around any complicated statement. You first want this evaluated before the comparison with 20 is done. That's all for now.